What is escape velocity? Imagine a cannon shooting upwards in the sky. You will notice that it goes up to a certain height and falls. Let's try again one more time, but with a lot more power. And somehow we can manage to shoot the cannon with very high velocity so that the body escapes the Earth's gravity and reach the outer space and will never come back again. This also is known as escape velocity, or in other words, the minimum velocity needed by an object on the surface of the Earth to overcome the gravitational force and escape to outer space.
Let's derive the formula of escape velocity. Let's assume that we have to launch a rocket into space from any planet. Consider the mass of the planet is equal to m. The radius of the planet is equal to r. The mass of the rocket is equal to small m. Potential energy of rocket on the surface of planet is minus g m upon r. Let's call this equation 1. The small r is the distance between the object and the center of the planet. Here, the negative sign implies that the force is attractive in nature. Also, potential energy of the system is always negative. At the time of the rocket launch, the kinetic energy on the rocket is equal to half mv squared. Let's call this equation 2. This VE here is what we are looking for, which is escape velocity. Comparing the two equations gives us the minimum velocity required to overcome the potential energy of the planet, that is, escape velocity, is equal to the square root of 2g m by r. Here, the capital R is used because the rocket is launched from the surface of the planet, which is equal to the radius of the planet. From this relation, we can note that the escape velocity is independent of the mass of the rocket. It only depends on the mass and the radius of the planet. Therefore, a rocket having minimum velocity equal to or greater than escape velocity then it will follow a curved path and will escape gravitational pull of the Earth. However, if the rocket is launched with a velocity less than escape velocity, then it will fall back on Earth due to gravity. This capital R is used because the rocket is launched from the surface of the planet.
Extra info. Escape velocity is different for different planets depending upon the gravitational pull, which is a function of mass of the planet and its radius.